Excellent. Now, I understand your company has not some, but has quite a bit of expertise with environmental isotopes. First of all, can you tell me what an environmental isotope is? Because I know some of our viewers may not know. And secondly, can you tell us a little bit about that expertise?
Yeah, I can. Certainly, again, Dr. Sklash, Dr. Vakili, who work for us, are our isotope specialists, if you will, and their expertise lies in that. I don't purport to be the isotope expert on that, but basically isotopes are, when you think of a chemical, it basically is two different forms of that chemical. A chemical will have, you typically think of a chemical with a nucleus with protons and neutrons and electrons that go around the atom in that. And when we look at the structure of that, the isotope has, if you have two different isotopes, this one will have a proton, this one will have a proton, this one may have a neutron, this one will have two neutrons. So it has different number of neutrons, which gives it a different mass.
Gotcha.
But it's the same chemical, it acts the same, but it can be used to differentiate because of their mass differences.
That makes sense.
So again, I'm not the chemist side of it, but we use that isotopic chemistry to help our clients. It's one of the tools that we use to differentiate these chemicals. So we can tell in certain instances, again, I mentioned that some of our clients have the finger pointed at them and said that you put this chemical in the ground, and we can look at that through isotopes and sometimes help our clients say, well, wait a minute, this is different than, we use that chemical, but this is a different form of that chemical than this is, and we're able to separate that. We do that in nitrates in groundwater. We do that in chlorinated chemistries, which are big trichloroethylene and perc that's used in dry cleaners and things like that.
Wow, that has to be a huge advantage.
Yeah.
That's amazing.
You can also, it's interesting, and people find it interesting, you can also date groundwater. So you can understand through isotopic chemistries how old that groundwater is.
Wow.
And you know, if it's tens of thousands of years old, that you can use that knowledge to say, well, if it's 10,000 years old, our chemical couldn't have gotten to it in that amount of time, or it takes a long time to recharge. So you can use not only in differentiating the chemical itself, but also in how old is that groundwater.
That's fascinating. Yeah. Turns it into almost sort of an archaeological study in some ways too.
It does adapt, but we always look at it, it's a puzzle.
Sure.
And there's a lot of pieces that have to come in and make sense and go together. And you know, again, this is a tool that we use as part of that puzzle to help build the right picture for people.
Makes perfect sense.